Hello, this is Professor Stephen Neshaba, and I'm here to help you out with the first step in the computational lab on using automated optimization for equilibrium problems. And I'll just take us straight to the first equation that we're going to be working with, which is equation 1 here. That's the reaction of carbon dioxide with H2 to produce carbon monoxide and water. And if you are working along with this, what you'll need to do is set up your first ice table for that, which is right here. And if you haven't done all that, then you should pause and construct that, write that down in your laboratory notebook. Okay, assuming you've done that, that means I'm looking at initial concentrations of 0.05 across the board, and we need to sort of set that up in Excel. So here we are in Excel. You should probably launch Excel and lay out your table this way as well. Okay, now what do we have to do? What I have in blue here is our target concentration of the carbon monoxide. It's lower than that right now. And so I'm going to have to set up a change variable that will let a little bit of CO2 react. And to do that, I'm going to enter in a formula, that is to say, equals, as x is going to be how much goes forward, so I need to say I'm going to lose a little bit, so it's minus x. There we go. And you can probably figure out that that's the same that you want to do here. So equals minus x again. Now, what are you going to put in here? Maybe you should try to guess what that might be. Okay, I'm going to think that I have to produce a little bit of carbon monoxide, so I'm going to say that's just equal to plus x, or just x. And the same thing here for the water, equals x. And there we go. Now, what are we going to put in for this equilibrium value? You know, it has to be the sum of the initial value plus the change. Maybe you can figure out, take a shot at that one right now. Okay, this is what I think I should do. I think I should say the equilibrium value for CO2 will be equal to that initial value plus the change. And I'll hit return. Okay, now of course it hasn't changed because I've said there's no value for x. X is 0. How are you going to fill in those values off to the right? Well, you could fill them in just by repeating what we've just done, but it turns out since the rule is the same, I'm just going to pull it over just like that. So the last, or second to last step here is I need to have an expression for a rule for calculating the Q, the thing that looks a lot like the equilibrium constant, but it's for whatever concentrations happen to be in the mixture at any given time. And go ahead and take a shot at that one. Okay, I think that what I should do is say Q is going to be equal to, I know it's the products over the reactants, so that's carbon monoxide times the concentration of H2O divided by, now I know I'll have two things in the denominator, so I'm going to say parentheses that times the concentration of H2. I'll close those parentheses and hit return. So I've got a Q value of 1, that's okay. And I can just play with this a little bit. If I put in 0.01, for example, here for x, that changes everything. I lose a little bit of CO2, and I gain a little bit of CO. Now, that concentration of CO is not quite up to what our target, supposedly our measured concentration of CO is. So, well, I could just change this by hand, and that's what I want you to do. Go ahead and try that, and until you get to the value that until you produce a value of CO that is supposed to match. That's equal to 0.09. Okay, now I'm just going to go ahead and move on to the part of that has to do with this goal seek. So I'm going to go down here and pick up goal seek. Now that brings up a window, and it says I want to set some cell, but I want to set this cell right here. That's the concentration of carbon monoxide, because I happen to know it should equal to 0.0194. And so I'll put that right here, 0.0914. That's the value I want it to be. How are we going to make it take on that value? Well, we're going to see if Excel will adjust the value of x to make that happen. And I think that we'll just see how that works. And works along, and indeed it found a result. Let's see, did it produce a value of carbon monoxide at equilibrium equal to the value we want? Yes, it did. That means that x must be 0.0414, and as an extra, it's already calculated the value of q, and since this is now at equilibrium, that q must be equal to the value of the equilibrium constant.